The passenger in a bus. The passenger standing in a bus in a stationary position, but the relative motion of the passengers in a bus is equal to the velocity of the bus. The passengers are moving along with the bus with the displacement equal to the rate of displacement of the bus. A person walking in a train in a forward direction. The speed of a person walking in a train is relative to the speed of the moving train. The walking speed of the person would be a, but in another frame of reference for the observer standing outside the train, the speed of the person is relative to the train. Since the person is moving forward direction with the moving train velocity b, then the relative velocity of the man is a plus b. The table moved with a stack of books on it. The stack of books is at rest, hence the velocity of the book with the reference point on the table is 0. But for viewers, the velocity of the books is relative to the speed of the table. Passengers on the roller coaster. The passengers sitting on a roller coaster will see that the other passengers are stationary and not moving in his frame of reference. The relative motion of the passenger with the frame of reference of another passenger is 0. But the actual speed of the passenger is relative to the speed of the roller coaster. The vehicle close by moved in the backward direction. You must have noticed sitting in a vehicle, if another vehicle standing stationary moves ahead, then as per your frame of reference you feel that the vehicle in which you are sitting is taken backward. If the same vehicle is taken in the backward direction, it appears as if your vehicle is moved forward and vice versa. A boat floating on water. A boat floating on the water appears to be stationary with the frame of reference of the ocean waves. For a person standing in a boat in open water, it appears to him that the boat is stationary because his relative speed matches the speed of the boat. Marching. For a person marching in a group, the speed of the other marchers in a group in his frame of reference is 0 because all the members are moving at the same speed and hence appear stationary. Two friends walking together. If the two friends are walking together at the same speed, then the relative velocity of both with respect to each other will be 0. For a person standing in a boat in open water, it appears to him that the boat is stationary because his relative speed matches the speed of the boat. Clock in the bus. A clock in the bus is moving with the relative speed of the bus. A clock is actually stationary, fixed at one point. For any point of reference from the bus, the velocity of a clock is 0, but for a point of reference outside the bus, the velocity of a clock is relative to the velocity of the bus. Bicyclist riding in the rain. If the bicyclist riding a cycle in a rain at a certain velocity, he will notice that the speed of the rain is more than the actual speed of the raindrops. For his point of reference, the relative velocity of the raindrop is the velocity of the raindrop plus his velocity, hence he feels that the speed of the rain is more than the actual. Skiing. The relative velocity of the skiboard in the reference point of the skier is 0 because he is standing on the board, which is moving along with him. While for another reference point the relative velocity of the skier is relative to the board. Geostationary satellite. The geostationary satellites are those mounted 36,000 kilometers above the surface of the Earth, and the speed of the satellite is in sync with the speed of the Earth. Hence, the speed of the geostationary satellite from the reference point of the Earth and the satellite appears to be 0. Kayaking. The relative speed of the kayak depends upon the speed of the water current. If the kayak moves in the direction of the current, then the relative speed of the kayak will be the addition of the speed of water flow and the kayak. In contrary, if the kayak is traveling in the direction opposite to the flow of water, then the relative speed of kayak will reduce. Swimming. If the ocean waves are approaching the swimmer, the relative velocity of the swimmer will be lower than his actual velocity. For a swimmer, it will appear that he is moving faster, but the speed of the waves decreases the velocity of the swimmer. Writing in helicopter. The relative motion of a person sitting in a helicopter is equal to the speed of the helicopter because the person is in a stationary position. Sitting on a swing. The speed of a girl sitting on a swing is in relative motion with the oscillating swing. A girl is sitting stationary on the swing and her actual velocity is 0. But since she is in motion along with the swing, her relative velocity is equal to the velocity of a swing. A ball passed to the player approaching towards him. For the player who is passing the ball, the velocity of a ball will be the actual velocity, but for a catcher who is approaching the ball, for him, the velocity will be more than the actual. The relative velocity in his point of reference is the addition of the velocity of a ball and his running speed towards the ball. A vehicle crossing a bicycle rider and a car. For a car driver, the relative velocity of a vehicle will be more compared to the relative velocity with respect to the bicyclist. This is because the speed of a car is more than the bicycle. For two objects appearing towards each other, the velocities add up. Mobile kept in a pocket while walking. The relative velocity of mobile is equal to the walking speed. Mobile in a pocket is stationary with a reference point of a carrier. Object released from the moving car. Any object thrown out from a running car moves backward from the car because the car is moving forward, and hence with the frame of reference of a person sitting in a car, he will see that the object is moving backward. Frequently asked questions. What is the relative speed of a bicyclist moving with a speed of 4 meters per second and a car at a speed of 75 kilometers per hour moving away from each other? Given, speed of car v1 equals 75 km/h equals 20.83 meters per second. Speed of man v2 equals 4m/s. Hence, the relative speed of two diverging objects is v equals v1 v2. v equals 20.83 plus 4 equals 24.83 m/s. The relative speed between the two is 24.83 meters per second. What is the relative velocity of a kayak riding at a speed of 10 meters per second against the river current of the speed of 8 meters per second? Given, speed of kayak v1 equals 10 m/s. Speed of river v2 equals 8 m/s. Hence, the relative speed of the kayak is v equals v1 v2. v equals 10-8 equals 2 m/s. The relative speed between the two is 2 meters per second. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.